So the next thing that we have in factoring kind of goes back to when we had, say, 5x plus 3x. All right, so we had 5 x's and then 3 x's. So what we really ended up with was 5 plus 3 x's, right? Except we just went straight to calling it 8x. But we had 5 of something plus 3 of something gave us 5 plus 3 of something, or 8 of something. 5 somethings plus 3 somethings is 8 somethings. And this is where it comes from. So you can actually do the same thing with factoring. You can have a problem that might say 5 times x plus 3 minus 7 times, let's do it, plus 7 times x plus 3. What you can actually do, and this isn't really factoring, but you can say, well, I have 5 blahs plus 7 blahs, so that must mean that I have 5 plus 7 of those, or 12 blahs, right? So I've got 5 blahs plus 7 blahs. If I have 5 of these and 7 more of them, I've got 12 of them. And we can show our work by adding this intermediate step. All right, so we actually use this in factoring. Say we had, why is the thingy there? Say we had something like, say, instead of 5 and 7, say we had 5y times x plus 3 plus 7 times x plus 3. So we've got 5y somethings plus 7 somethings. So that means that ultimately, at the end of the day, if we have 5y somethings and 7 somethings, we're going to have 5y plus 7 somethings. Oops. So this is actually a really, oops, forgot my thingy. This is actually a really useful factoring skill, is to do, is to see these relationships and combine, combine like terms to simplify things and make them easier to solve later when we take the next steps after factoring. So a couple more examples. Say we had 8x times, say, y minus 4. And then we had 9x cubed y minus 4s. So again, we have 8x of somethings plus 9x cubes of somethings. So that means ultimately we're going to have 8x plus 9x cubed of something. Okay, 8x of something plus 9x cubed of something is 8x plus 9x cubed of, again, something. If you have minus signs, all of those need to apply. So if we had, why do I keep doing that? So if we had, say, 16y squared times 3x plus 4, to start to make it look crazy, minus 3xy times 3x plus 4. So again, this isn't supposed to be weird or freaky or anything. The whole idea is just, as you see, there's a pattern. Okay, I've got 16y squareds of something, and I'm subtracting off 3xy's of it. But it's the same thing. I've got 16y squared of blah minus 3xy of blah. So that's going to come out to 16y squared minus 3xy of blah. And the point is, we don't care what this blah is, as long as this is the exact same thing. As long as these are the same, don't even worry about it. Just like put a flower on it or whatever makes you happy. I'm into flowers. Whatever makes you happy. And don't even get worried about what those variables are. I mean, it's not to, I hate to say it, just turn your brain off and just do it. See what they have in common and add or subtract those together as the problem would indicate. Let's try one more example. Say we've got, oh, I don't know, z times, let's call it negative z times y plus 4, plus 3z squared times y plus 4. So we might say, it's z's, I don't like z's, and I completely understand, but nonetheless, we must continue. So we see I've got negative z of those, plus 3z squareds of those, and I don't really care what those are, but I've got this same term, this is the same, it's the same over here, as it is over here. So I've got minus z of them plus 3z squared of them. And that's it. This is like apples. I have negative z apples plus 3z squared apples is negative z plus 3z squared apples. And that's all you need to do. Just recognize the patterning, go for it.